So today we're going to be looking at integrating complex functions of a real variable. So suppose f is a complex valued function of a real variable t, then we can write f of t is u of t, which is the real part, add I, which is square root of minus 1, v of t, which is the imaginary part, and then when we integrate that with respect to t between a and b, we can integrate the reals and then we can integrate the imaginary separately and that add them up, and that gives us the solution, which is what you would expect. Now the fundamental theorem of calculus applies when we're integrating. The reason being, even though we're integrating a complex valued function, if this is our argon diagram here, and here's the imaginary and here's the real, because we are integrating real variables, we are integrating along the real line, and so therefore there is only one possible path, which is why we can use the fundamental theorem of calculus. When we do another subsequent video, we may, for example, look at, if we're including the complex, we may, for example, look at that path or this path between this and this, but as we are only looking at reals, we are only integrating along the real axis, and there is only one path, which is from A to B along the real axis. So what we're going to do is we're going to do 5 questions of increasing complexity. Here's the first one. Just pause the video if you want to have a go. Okay, so we got f of t is equal to 2t add I t squared, so it's complex, from t equals 1 to t equals 0 to t equals 1 along the real axis, so t is real. So basically we have f of t is 2t add I t squared, and so therefore the integral of f of t between 1 and 0 dt is equal to, as we've just said above, the integral between 1 and 0 of the real part, 2t dt, add I times the integral between 1 and 0 of the imaginary part, which is t squared dt, and this is going to look mighty familiar. So there, the integral of 2t is t squared between 1 and 0, add I times the integral of t squared is t cubed over 3 between 1 and 0, and that equals 1 add I over 3, as simple as that. And that is the answer to question number 1. Okay, so let's go straight on to question number 2. So pause the video if you wish to have a go at that. Okay, so here is our complex function, and we have t 0 to 2 along the real axis. So again, t is real. So therefore, we have the integral of f of t dt between 0 and 2 is equal to, well, there is no real part here, it's just the imaginary part here, so that is equal to the integral between 0 and 2 I e to the t dt, and we know that that is I, well, the integral of e to the t is e to the t between 2 and 0, which equals I e squared minus e to the 0, which is 1, and that is the answer to question 2. Okay, we're racing along these. They do get a little bit harder. Question number 3. I'll pause the video if anybody wants to do it. Okay, so for real t, what is this integral here? Okay, well, so basically they're already given us. There's only an imaginary part to this. All we've got to do is integrate. Well, the integral of e to the it is 1 over I e to the it, and that's between 0 and 2 pi, which equals 1 over I e to the 2 pi I minus e to the 0 I, just putting these into there. Now if we have a quick look again at our argon diagram here, e to the 2 pi I, well, 2 pi is going all the way around there, and e to the 0 I is also 1, so they're actually the same. They're both equal to 1, which is 1 over I 1 minus 1, which equals 0, and that is the answer to question 3. Okay, now question 4, getting a tiny bit harder now. We're going to do 2 methods for this one, so again I'll pause it if anybody wants to do it. Okay, good. So basically what we can do is we can separate here the real, and this is method A that I'm going to do. So we separate the real and the imaginary. So that's the real is cos t dt add I, the integral between 0 and theta of sine t dt. So far so easy, and that equals sine t between theta and 0 minus I cos t between theta and 0, and that equals sine theta minus I cos theta minus cos of 0, which is 1. So that equals sine theta minus I cos theta add I. And we can just make this slightly nicer. Let's put as 1 over I. Let's take 1 over I out, and that gives us I sine theta minus I squared cos theta add I squared. And that equals 1 over I cos theta add I sine theta minus 1, which equals 1 over I cos theta add I sine theta is e to the I theta. So that's e to the I theta minus 1. And that is the answer. And that's method 1. But we are going to do another method, because what we could do is we could rewrite this here as e to the I, oh sorry, not e to the I theta, oh my bad, e to the I t. So instead of cos theta add I sine theta, cos t add I sine t, we could write it as e to the I t. So we could integrate between 0 and theta of e to the I t dt, which equals, again this is quite similar to one we've just done, 1 over I e to the I t between 0 and theta, which again is quite quicker to get to this point here, e to the I theta minus 1. So it's obviously the same answer, but that is a second method, is just noting that we could rewrite that in its polar form. That's question 4. Now question 5 is actually quite interesting. It's a little bit trickier. Pause the video and let anybody do it if they want to. Okay, so I'm going to do 2 methods again. Alright, so the first method, what we're going to do is let's just tidy this up a little bit by multiplying by I over I. So that gives us the integral between 1 and minus 1 of minus 1. Obviously I times I is minus 1 over minus I minus t, and then we can multiply top and bottom by minus 1, which gives us the integral between 1 and minus 1 of 1 over t plus I dt. Now I, we can just treat it as if it's a normal constant like 2 or whatever, and we can integrate this because we're dealing with the reals, and that will be, well, the integral of 1 over t plus anything is log of t plus whatever, so that gives us log of t plus I between 1 and minus 1, which equals log of 1 plus I minus log of minus 1 plus I. So now we've got to work out what these 2 logs are. Well, let's have a quick look at our Argon diagram again. Here is 1 plus I, and that's root 2, and this is pi over 4, so that's 1 plus I, and minus 1 plus I is here, where that's root 2, and that is pi over 4, and that's minus 1 plus I. So basically we can rewrite these 2 as log of, well, 1 plus I we can write in polar form as root 2, which is the modulus, e to the I pi over 4, minus, and 1 minus I we can write as, remember we have to measure the angle from here, which is 3 pi over 4, minus log of root 2 e to the I 3 pi over 4. And expanding all this out, we get log root 2 add log of e to the I pi over 4 minus log root 2 minus log e to the I 3 pi over 4. The log root 2 cancels, and the log of e to the power of anything is just equal to the anything, so that's pi over 4 minus I pi 3 over 4. Well, I pi over 4 minus I pi 3 pi over 4 is equal to minus I pi over 2, and that is the answer. Okay, now what we're going to do as well, we're going to do another method. We are going to convert this to the more usual x plus iy, i.e. the real and the imaginary. So let's try and do that. So basically we have, what was it again? I over minus 1 add it. So we got the integral of minus 1 over, I over minus 1 add it dt. That's what we're trying to do, isn't it? Yep. Okay, so let's put it in the form x plus iy. So we got I, and we multiply by the conjugate of that. So that's minus 1 minus it over minus 1 plus it minus 1 minus it. And that gives us minus I plus t over 1 plus t squared, which we can write as t over 1 plus t squared, the real, minus I over 1 plus t squared, the imaginary, which is in the form x plus iy. So now the integral of I over minus 1 add it between 1 and minus 1 dt, we can rewrite in real form the integral of the real part, which is t over 1 plus t squared dt, that's the real part, minus I times the integral of the imaginary part, 1 plus t squared dt. There we go. That's that. Okay, so now all we need to do is we need to evaluate these. Well, this one here is log of 1 add t squared over 2 between 1 and minus 1. Minus I, well, the integral of that is tan to the minus 1 of t, tan to the minus 1 of t between 1 and minus 1. Okay, so putting 1 in here, we get log 2 over 2 minus log of, well, putting in minus 1, we get log of 2 over 2, so that equals 0, minus I, tan to the minus 1 of 1 is pi over 4, minus tan to the minus 1 of minus 1 is minus pi over 4. If we just look at our 4 quadrants, that's pi over 4, and that's minus pi over 4, all stations to crew, which equals, well, that cancels, minus I, pi over 4 add pi over 4 is pi over 2. So that is the solution, which is identical to the one that we found there. So basically, we've done these 5 questions. None of the maths is particularly hard. It's just a question of getting used to them a little bit. And what we're going to do in the next video is, in this video, of course, what we did was we have done complex, where are we? We have done, complex functions, integrating them with real variables. What we're going to do in the next one is integrating complex functions of complex variables, which is slightly different. Okay, well, I hope you've enjoyed this and found it useful. If you have, please press the little thumbs up button. It takes 1 second. And subscribe to the Gresti Academy YouTube channel. Thank you.